All right, let's finish section 11.3. Then you can be working on homework. All right, here, the problem involves two cards are going to be dealt successively. That means one after another. It's without replacement from a standard deck of cards. Find the probability we get two face cards. Okay, so based on the notation we were using earlier, let's think about this. So this is without replacement, remember. We want the probability of getting a face card on our first draw and a face card on our second draw. Okay, face card first and face card second. Okay, so let's think about this. This is going to have two fractions and we're going to multiply them. All right, now before we make our first draw, there are 52 cards. And then when you think about a deck of cards, the face cards are just the jack, queen, and king. And there's 4 suits, so there'd be a jack, queen, and king for clubs, spades, hearts, and diamonds. So that means there's going to be 12 face cards. All right, now you assume that you got that face card. Then what happens to it matters. In this case, this is being done without replacement, which means that face card is no longer in that deck. So the probability of getting a face card on my second draw is going to be different because there's only 51 cards in the deck and only 11 face cards left. And so you would do 12 over 52, multiply that by 11 over 51, and that's going to wind up simplifying to be 11 over 221. Okay? All right, now let's think about this second one. Let me see if I can get just a little more space here. Okay, so the second situation, the first card, I want the probability that the first card is a jack, so a jack of any kind, and second card is a jack first and a face card second. All right, so let's think about that. All right, so we're going to have the probability of getting a jack first, probability of getting a face card second. So the probability of getting a jack first, well, there's 4 jacks and there were 52 cards before I made that draw. Now, remember that we're dealing these cards out without replacement, meaning after that first card was dealt, it stayed out. So we don't have 52 anymore. We only have 51 cards. And a jack is a face card, so we're not going to have 12 face cards. We're only going to have 11, and we would multiply those two together to get our answer. And that would be 11 over 663. So as you're doing these and problems, always think about this second part right here as if the events are not independent, then that's are not necessarily independent, then that's a safe way to do it. Always think about that first draw and what happened with that card after that first draw, and just do your next probability based on that. Since this was done without replacement, the events were not independent, and what you got on that second draw did change based on what happened on your first draw. So just always think that on all problems. Think about what had happened on that first draw. All right, now this is the trickiest problem because this one is asking you what's the probability, okay, that you're going to get a face card on your second draw given that the first card was a jack. All right, so the problem with this is that you're really just wanting the probability for that second card being a face card. The answer is just the probability for that second card being a face card. You can just think about it that way. It's just that you have to assume that the first card was a jack. So you started out with 52 cards. But on this one, your first card was a jack, so you now only had 51 cards. And then out of those 51 cards, you already got a jack. You're only going to wind up having 11 face cards. So it's this. So it's really just let me write it here. It's really just the probability of the second card being a face card, assuming that you already drew a jack the first time. Okay, so it's really not multiplying anything. It's really just the probability for that second card being a face card. It's just that you're assuming you've already drawn a jack on your first draw, which means you're down to 51 cards and 11 face cards. Okay. All right, now I want to look at this. This is one way of organizing data that you might get from a survey. Venn diagrams is another way, but this thing we're looking at is called a contingency table. Let me get that back up there. Okay, this is sometimes called a two-way table or a contingency table. So what I want you to think about is there are 100. They had 100 people complete a survey. They had them record whether they were male or female, and they also had them record whether their career motivation was to make money or to be creative or to give back to society. So the people indicated whether they were male or female, and also which of those three things was their primary career motivation. All right, so let's work through this problem, and then I'll do a couple more of this type, or I'll do at least one more of this type in class next week. All right, so find the probability the student is male. Okay, so notice how it's organized with the totals for these things. So probability they're male, well, there's 52 male students out of the 100, or male respondents out of the 100 people who responded to the survey. Then I would simplify that. My calculator can do the simplifying for me, and I'll get 13 over 25. All right, now, next question is, what's the chance I'm going to reach in and grab a survey, and it will be for someone who is not motivated primarily by money, so that it won't be one of these. Okay, so one way you could do that would be, then they must be motivated by either allowed to be creative or giving back to society, and you could do that to find the answer. So 38 plus 31 is 69 out of 100. You could have also been thinking there were 100, and if they're not motivated by money, you could subtract the 31, and that's another way to get the 69. Okay, so either of those are good ways to think about it. Now this one is one that has that given that. So this one is saying, what's the probability? What's the probability I'm going to get a female? Going to reach in, pull out a survey for a female, given that the primary motivation was, I'll just say, giving to society. Okay, so remember how we thought about that giving to society, meaning that you're not going to really be considering all 100 of the surveys. But you have to be careful. You're going to be restricting it to those whose primary motivation was giving to society. So what that means is you're really just looking here. And then the question is, what's the chance of getting a survey for a female, assuming that you're focused here? So you're restricting your sample space down from all 100 to just those whose primary motivation is given to society. So your denominator is not going to be 100, it's going to be 31. And then number of females out of that is 14. So your answer would be 14 out of 31. Okay. All right, so again, that's just called a contingency table or a two-way table. It's just a way to organize data. Kind of, Venn diagrams is another way, but this is sometimes the way people will organize survey results.